Hello everyone, welcome back to Genie. In today's video, we are going to discuss about design patterns. These are the agenda for today's video. First is we will have a short introduction on what is design patterns and a brief history of design patterns. Then we will go through the classification uh, and the three types of design patterns. So design patterns, what are design patterns? Design patterns are actually the solutions to some of the common problems that we face in software design. So design pattern is not like writing a specific code or something, uh, but it is a concept of solving a particular problem. So you have a problem and you need to find a solution for that. So we use design patterns to do so. And algorithm, what does algorithm means? Algorithm, it is a set of instructions uh, to achieve some goal. But design pattern is actually a high level description or to solve a problem. Why do we actually need to learn design patterns? Because they are already tried and tested solutions to some of the common problems we face while we are designing a software. Also, the code will become more modular, flexible, and easy to maintain. And also, it will improve the standard of communication between the developers. So, in design patterns, you can use the standard terms we use like like if you encounter a problem, you can tell to the fellow developer that it can be easily solved with a facade problem, like that. So, facade pattern like that. So it improves the communication among the developers. So these are some of the advantages of using with design patterns, and we will talk about some history. The concept of design patterns was first introduced by these four authors: Eric Gama, John Blisides, Ralph Johnson, and Richard Hem, and they published a book called Design Patterns: Elements of Reusable Object-Oriented Software. And it became a very bestseller very quickly. This book was fondly remembered as book by Gang of Four or the GOF book. According to the Gang of Four, the design patterns are divided into three. Creational design pattern. So the Gang of Four has written their books according to the OOPS concepts or object-oriented programming concepts. So in object-oriented programming, everything is focused on the object. So here in the three classification of design patterns, the first everything is based on object. So first is creational design pattern. So it focus on creating the objects, creating and how they can be initialized. This creation design pattern actually focus on that part. Next comes structure. So structural design pattern is like so in the OOPS concept, everything is object and classes. So in structural design pattern, it is to structure this into like if you want to organize objects and classes into a larger structure, we use structural design pattern. Then comes the behavioral design pattern. Behavioral design pattern deals with how these objects communicate with each other and their responsibilities are distributed. So creational design pattern hides the creation logic. So how do we actually create a new object? We use the new operator. So instead of using new operators, um, it hides actually the creation logic. Then it gives more flexibility in solving the problems. These are the five design patterns we have in creational design patterns: factory, abstract factory, singleton, builder, and prototype. In our video, we will go through two design patterns of from each category. So in creational design pattern, let us go through singleton and factory design pattern. So factory is a design pattern. It provides interface for creating objects in the superclass. So you can create some object in the superclass, but it allows the uh, subclasses to determine the type of objects that can be created. So object will be created, as you can see in the diagram. There is a logistic superclass. It has got a method create transport. So here new transport will be created. So this transport will be created from here. And there are two subclasses, road logistics and sea logistics. Both inherit this method, create transport. So they can decide, or the subclasses can decide the type of objects that will be created. So object creation logic is hidden in this logistics class, but this can decide which object needs to be created. So that is creator that is the factory design pattern. So let us go through the class diagram. We have a product uh, interface. This is the so this is something which is created by the factory. Okay. Now this is the creator. It returns instance of an abstract product. Now there are two subclasses. The concrete creators implements this creator patterns, and here it defines what type of product has to be created using this create product. Next pattern in creation design pattern is the singleton. So singleton ensures that a class has only one instance every time when you access it, and then that instance has got a global access throughout the program. There are situations where you need to initialize or create some objects only once, like opening a new database connection, creating loggers. At that time and all, you need only one single object. So in that cases, you can use singleton. So how do you create a singleton? First is using a private constructor. So if it is a private constructor, it prevents calling that class from outside. So object creation will be restricted. Static instance. If there is a static instance, um, it returns the same instance every time it is called. Then a lazy initialization. So instance is created only when it is first requested. So this is achieved by using lazy initialization. Okay, so imagine you stand in a room with lot of doors, but every time when you open a door, you will see the same person. So singleton design pattern is something similar. This is the class diagram. We have a private constructor and a static method instance to retrieve the singleton instance. And there is a client which use this instance method to gain access to singleton instance. Now, structural design pattern. Structural design pattern explain how to assemble the objects and classes into larger structures. These are the seven structural design patterns. We have composite, flyweight, proxy, facade, adapter, decorator, and bridge. In this video, we will go through adapter and decorator design patterns. So adapter pattern, adapter as the name suggests, it is used to create something for something that are not compatible. So adapter pattern, it allows in objects with incompatible interfaces to work together. It acts as a bridge between two incompatible things or interfaces, converting the interface of one class into another interface that the client expects. So that is what usually adapter pattern does. As you can see in the example, there are two applications, stock data provider and analytics library. One returns the output as JSON, another returns the output as XML. Now, these XML and JSON are two incompatible types. So, we will create an adapter. So, our application needs the input in XML and return the output in JSON. So, we are creating an adapter XML to JSON adapter here, which takes the XML as input and returns JSON as output. This is the class diagram. There is a target that is expected by the client. Adapter, it adapts the iTarget interface. There is an adaptee with the incompatible interface. And there is a client. It consumes the adapter to interact with the adaptee through iTarget interface, as we saw in the previous diagram. Next design pattern we have is the decorator design pattern. So decorator design pattern is also a structural design pattern. It adds behavior to additional objects, individual objects, without affecting the uh, behavior of other objects from same class. So if you want to, it is just like the pizza topping. You have a base pizza, its functionality does not change. But if you want it, but if you want some toppings to be added, like if you wanted a pepperoni topping, the base pizza does not change. Only the decorations on that will change. And if you want to have a uh, paneer pizza, the again the uh, the toppings changes. So that is what decorator pattern also does. It allows to add new functionality to our object without altering its structure. This is the class diagram. So there is a component interface. It is shared by the concrete component as well as the decorator. So uh, it defines the objects that have responsibilities added. So here only the objects with the additional responsibilities will be defined. There is a concrete component. Here, this is the base class or object to which the additional responsibility will be added. It implements concrete this component. So here we need to add the additional responsibilities. How do we do that? Using the decorator. So this is decorator is an abstract class. It implements this component interface and contains reference to the component object. So it has a relationship with the component class. Next comes concrete decorators. Subclasses of the decorator class. They add a specific responsibility to the component by extending its behavior. So this is how the class diagram of decorator design pattern looks like. Next comes behavioral design pattern. So behavioral design patterns focus on how these objects communicate with each other, and it helps in managing the algorithms, responsibilities, and pattern of communication. There are around nine behavioral design patterns: chain of responsibility, command, iterator, memento, observer, template method, strategy, state, and mediator. In today's video, we will talk about mediator as well as observer. So mediator actually promotes loose coupling. Instead of the objects communicate with each other, there is always someone called as a mediator through which they communicate to the mediator object. This is useful in scenarios where many objects need to interact with each other, but they should not be tightly coupled. This is the class diagram. There is an I mediator interface. It defines, so this is the colleague. So this is the one which is, as you see in the previous example, we have so many objects in the space like aeroplane, helicopter and all. What will happen if they communicate with each other? There will be confusions and there can be even accidents. So to prevent that, we have this mediator here. So this one actually communicate with each of these objects. So these are called these objects are called colleagues, and this is called mediator. So this is the class diagram, and here colleague represents the objects that need to communicate with each other, but they do that through mediator. And the concrete colleague, this extends from the colleague interface, and there is a concrete mediator that implements the mediator interface. So mediator interface actually register the colleagues as well as send messages between them. Last pattern which we are going to discuss in this video is this observer design pattern. So observer design pattern, if you want to have one to many um, dependency between objects, we can use this observer design patterns. So when one object changes its states, the dependent objects are notified automatically. So it is like a publisher subscription method mechanism. So imagine we have published, we have subscribed to a magazine. So whenever a new magazine is published, automatically the subscribers are notified of the changes. So it is useful in scenarios where one object need to inform multiple other objects about the changes in its state without tightly coupling them together. This is the class diagram. There is a subject which defines the interface for attaching the observer, detaching the. So the subject can anytime um, unsubscribe from the observer. So this is the subject. It contains a list of observers to notify when its state changes. Concrete subject, it determines the subject interface and keep track of its state. There is an observer. It defines interface for objects that should be notified of the subject's state. And there is a concrete observer. It updates the observer interface and updates when notified by the subject. Then the conclusion. Design patterns are tools in software engineering providing proven solutions for common design problems. The developers can create code that is more flexible and easy to maintain. Design patterns actually provide code reusability. They encapsulate best practices. Understanding design patterns can improve the code quality. So we have talked about design patterns and we will go through each of the design patterns in details in our upcoming video. We will create a, an application for each of the using each of the design patterns. If you have liked watching my video, please do subscribe to my channel. If you are new here, please like, comment and share this video with all the coding enthusiasts. Thank you. We'll be back with another exciting video soon. Till then, take care. Bye.